Hello, in this video we are going to look at the graphs of a number of polynomials. We are going to be going to our graphing calculator and we'll be sketching our graph and making some decisions or conclusions about the graph from there. So the first one that we're going to do is this y equals x cubed plus x squared minus 9x plus 2. So I did take the liberty of going to my calculator and typing this in ahead of starting the video. So I have this typed in as my y1. I have a lot of other things in here, but I did turn them off. So I also have my plots turned off. If you need to do that, you arrow up to the plot and hit enter and come back down. When they're all not in a black box like this, they are turned off. For my window for this, I would like my window to go in the x direction from -10 to +10. And then I did work at this ahead of time. So in the y direction, I would like it to go from -10 to 20. And so from there, I am ready to look at my graph. And so this is the graph of this cubic function. And I'm going to sketch this graph back on my PowerPoint. So from -10 to +10 in the x direction, from -10 to +20 in the y direction. We had a cubic function that came up, curved, came down, curved, and went back up. So we are to take note of a number of different things. So the first thing is the leading coefficient. That's the number in front of the highest degree term. When I look here, it is not written, and so it would be 1. Next is extrema. Extrema are all of the minimums and maximums. It comes from the word extremes, and it is the plural form. And we talked about early in the course that the plural of minimum is minima and maximum is maxima, and we don't often use those formal plurals, but they are the true words. So as I look at this problem, right here, I have a maximum point, and right here, I have a minimum point. And so the number of extrema that I have are 2 extremes. Next, we're asked for the degree, and we've already talked about that that is the highest exponent. So in this problem, I see that it is degree 3. And then we're asked for the number of solutions. The solutions to this are the zeros. And so the places where it crosses the x-axis, where it has zeros, there are 3 solutions. So we're going to go to our next graph. And then after we look at our graphs, we will try to make some conclusions about all of these things. So I'm going back to my graphing calculator and to my y equals, clearing out this graph that we just had. And then for me, I typed this ahead of time, so I'm just turning on this graph. But for you, you want to type this graph, and you can type it as your y1. And then my window, I'm going to keep the same, and so I will hit graph. So I get a very different looking function for this quartic function. So I'll go back to my PowerPoint and sketch this and then write down the key things. So our graph was the same size, -10 to 10 in the x direction, -10 up to 20 in the y direction. And we had this graph that was very M looking. It had better symmetry than I'm able to draw, but that's the idea. So leading coefficient, this is the number that leads the polynomial with the highest degree term, and so it is -3. Extrema, we said those are the maximums and minimums, so I have a high point, a low point, and another high point, which gives me 3 extrema. Degree is the highest exponent, so looking here, I see that this is degree 4. Solutions, I see 1, 2 real solutions. And then I'm going to add in that there are 2 complex solutions. for 4 total. Now, without getting too far into the weeds on this, we studied linear, which always has one solution and is degree 1. We studied quadratic, which is degree 2 and always has 2 solutions. However, when the solutions for quadratic do not show up on the graph, then they are complex. So using that same logic, we looked at a cubic, degree 3, with 3 solutions. And now we have a quartic, degree 4, and so following the pattern, it should have 4 solutions. I see 2 of them on the graph, and so those are the real ones. And then like we had with the quadratic, when they don't show on the graph, that means they're part of the complex numbers. They would include an I in them, an imaginary piece. And so we do have 4 total solutions, even though we just are seeing 2 of them on this graph. So going to our third graph, we'll go back to our graphing calculator, to our y equals. We'll clear out this problem that we just did. And I previously typed this, and so I'm coming back here and turning it on. And so then I will hit graph from there, and my graph shows up, but my window is not ideal. So what I want to do from here is to change my window. And so I'm going to go into my window, and I am going to change it to go from -2 So sorry there, a little interruption. I'm not able to pause the video, but we're going -2 to 10. And then in the y direction, we're going to go -10, and we're going to go up to 100 to get a good picture of this graph. So there I see a good picture of this graph, and I played around with that ahead of time. That's how I came up with those numbers, with some trial and error. So we'll go to our PowerPoint and attempt to sketch this out. So we went from -2 to +10. We went from -10 to +100. And our graph looked, it's kind of hard to draw. Came down here, and some bubbles here, went way up, came back down. So going back to my graphing calculator, yeah, I think we captured it. So leading coefficient on this, looking for that number, I see a -1. Extrema, I see 1, 2, 3, 4. Degree is that highest exponent, so that is 5. Solutions, I see 1, 2, 3 real solutions, so 3 real. I know there needs to be 5, so that means there would be 2 complex solutions that are not showing on the graph for 5 total. And so we will take a look at one last graph, and so we'll go back to that graphing calculator one more time. Into our y equals, clear the one we just looked at, and then you want to type this last one for me. I just want to turn that one on and hit graph. We are going to need to adjust our window again on this, and again, I played around with this ahead of time. So I want my window to go from -4 to +4 in the x direction, and then I want my window to go from -12 to +10 in the y direction. And we'll hit graph, and we see our image kind of looks like a W. So a little different, but somewhat related to what we had seen for the quartic one. So coming here, we have -4 to +4, -12 to +10. This is x, this is y. And we got this kind of W looking shape. And I think I sort of over exaggerated it. We can go back to the graph there. Looking for the extrema, I definitely have these two minimums here, but then in the middle of the graph, I also have a maximum, minimum, maximum as it goes across the y-axis. So I think I sort of exaggerated them in my picture, but leading coefficient is unwritten 1. Extrema are 1, 2, 3, 4, 5. Degree is highest exponent, so that is 6. Solutions, I have 2 that are showing up on the graph, so 2 real solutions. That means I would have 4 complex solutions because my total solutions has to match the degree, so 6 total. So then I'm going to take all that information, all these observations, and try to pull them together to make some conclusions. So what is the difference or the impact of an even or odd degree? So looking at my graphs, when I am looking at an odd degree, it would be the 2 here on the left. And the thing I notice with an odd degree is that the left and the right of the graph go in opposite directions. When I look at an even degree, which are the 2 on the right, the top one, both ends point down, the bottom ends both point up, so the ends go in the same direction. So if my degree is even, the left and the right of the graph go the same direction. So either both towards infinity or both towards negative infinity. And then if I have odd degree, the left and the right on the graph go opposite. And so one of them goes to positive infinity and one to negative infinity. And it will depend on that leading coefficient, which way it goes. So the leading coefficient, go back and look. Our first one, the leading coefficient was positive. Second one, leading coefficient was negative. Third one was also negative. And last one was positive. So the coefficient, that leading coefficient, we talked about with quadratic, it impacted whether it was concave up or concave down. With these polynomials, we have sections that are concave up, sections that are concave down, so it's not quite as clear cut. But what we see is that when the leading coefficient is positive, the right side of the graph will go towards positive infinity. So looking at these pictures, when my leading coefficient is positive, this right side goes to positive infinity, this right side goes to positive infinity. But when my leading coefficient is negative, the right side will go to negative infinity, and here again, when that leading coefficient is negative, the right side goes to negative infinity. Now, the left-hand side, well, it'll depend what that does based on whether it's an even or odd degree. So the leading coefficient really just tells you about where the right side of the graph goes. So what is the impact of the leading coefficient? If it is positive, the right side of the graph goes to positive infinity. And so that's like in the long run, the result of this graph. Because of that positive coefficient, it's going to positive infinity. And if that leading coefficient is negative, then the right side of the graph goes to negative infinity. Next, it asks us for what is the relationship between the degree and the number of minimum and maximum. And so the minimum and maximum are those extrema. And so if we look at the relationship between the number of extrema and the degree. So extrema is 2, degree is 3. Extrema is 3, degree is 4. Extrema is 4, degree is 5. Extrema is 5, degree is 6. And so in every case, the degree is literally 1 bigger. So the degree is equal to the extrema plus 1. And then finally, it asks us, what is the relationship between the degree and the number of solutions? And I talked about this already when we were graphing, that the degree equals the number of solutions. And that is the total solutions. So some of them are real, sometimes they're all real, some of them can be complex solutions that do not show on the graph. So the degree is that total solutions.